This is 9.1 Circles and Parabolas, Part 2. These are the objectives. This part of the video is going to emphasize the last two bullets. This is the vocabulary key concepts. It's basically going to emphasize standard form of a conic, focus, reflective property of a parabola, tangent line. Main emphasis on these two. Let's move on to the next slide. This is reflective property of a parabola. Follow along. Let me just introduce this picture. This is the parabola. This is the tangent line to the parabola. Notice this point of intersection between the parabola and the line. So let me read this to you. This is the tangent line to a parabola at point P. Here's point P. Makes equal angles with the following lines. The line passing through P and the focus. So this is the first line. The second line is the axis of the parabola, which is this line. And notice that these are the two angles that are equal. Now, hence we have an isosceles triangle. Since these base angles are congruent, you know that this side here is equal to this side. And we're going to be using this property on the following two problems. Let's move on to the next slide. It says find an equation of the tangent line to the parabola at the given point and find the x-intercept of the line. So you're looking at the parabola x squared equals 2y, and notice that this is a parabola opening up, and the vertex is at the origin. And so first let's do this. Let's find the focus. I can rewrite this the following way. Now at this point you should be able to see that P is equal to a half, opening up, so positive, and the focus has a coordinate value 0, 1 half. If I was to sketch this information, this parabola, this point, which is the tangent to the parabola, the point tangent to the parabola, and the focus, this is the picture that I have. Here's a given point, here's the focus, and notice that my goal is basically to find this point here. Let me highlight it. Because once I have this point, I have this point plus this other point, I should be able to find the equation of this blue line, which is the tangent line. The tangent line to the parabola at this point. So this is what I'm going to do. I'm going to find distance d1 using the distance formula. Simplify this, and you should be able to follow that this is equal to 5. So now, if d1 is equal to 5, you know that d2 is also equal to 5, so that's why I have the following. Notice that this is equal to 5. Why is this a half? Because the distance from this vertex to the focus is a half. So if this is a half, this has to be 4.5, which now I can find the coordinate value of the y-intercept, which is 0, negative 4.5. At this point, I have 2 points. I should be able to find the equation of the tangent line, the blue line. First I find the slope. It gives me -3. At this point, I know that the y-intercept is right here, -4 and 1/2. So I put this in slope-intercept form. This is what I get for the equation of the tangent line. Then I need to find the x-intercept. Basically, I'm looking for this point. Once I do that, I get -3/2, 0. And how do I find the x-intercept? I set the y equal to 0 and solve for x. Let's go to number 14. Same directions. Now you're looking at a parabola opening down. And here's a point that the tangent line goes through. So then, very similar steps to number 13. First, I'm going to rewrite this so I can find the focus. And I solve for x squared. I have the following. Then 4 times y is equal to -2. and it's negative 1/8, which gives me my focus. And again, it's opening down, so the P is negative. Now I should be able to find the coordinate value of the focus, which is this. Now I'm going to sketch all this information, the parabola, this point, the focus, and have the following picture. Just like on number 13, my goal is to find the coordinate value of this point. So what I'm going to use is I'm going to use the fact that d2 is equal to d1. I'm going to find d2 using the distance formula. I go through the math here, and I end up with 8 and 1/8. And then at this point, what this is going to help me, this coordinate value. If the distance from here to here is 1/8, because that is the coordinate value of the focus, I should be able to find the distance from here to here, which is 8. If this is 8, that means that this coordinate value is 0.8. Once I have this point, and I was given this point, I should be able to find the equation of the tangent line. Find the slope, which is -8. I know the y-intercept is +8. That's my b. Put it in slope-intercept form. This is what I get. And then at this point, I need to find the x-intercept, which is basically this point. And once I set y equal to 0, I get the x-intercept of 1, 0. Next slide. This is number 15. It says the revenue R in dollars generated by the sale of X 32-inch televisions is modeled by R equals, you go ahead and read the equation there, the expression. What you are hearing in the background is some rain. Anyway, let me continue here. It says determine the sales that will maximize revenue. So this is basically what you're doing. You are actually going to have to find the x value that generates the maximum r value. If you remember from algebra 1, this is actually a parabola, and this parabola is opening down. So that's why it's okay to be talking about a maximum. So to find the x value in algebra 1, you learn that the x value of the vertex is generated by this formula, the opposite of b over 2a. This is your a, this is your b. So then you substitute that information into your equation here, and you end up with the following. You simplify this, and you end up with 125. And since we're talking about televisions, so it takes 125 televisions to give you the maximum revenue. And this is just extra. What is the maximum revenue that you get? You plug in x equals 125 into the expression here, and it gives you the following. And again, they don't ask you to do this in the problem. This is just extra for fun. Let's move on to the next slide. Here's number 16. It says a simply supported beam is 64 feet long and has a load at the center. The bending of the beam at its center is 1 inch. The shape of the deflected beam is parabolic. Part A says find an equation of the parabola. You can read the assumed part. If you look at this picture, what you're going to have to do is to find the parabola. You have to actually use a point. And you are given this point, 32, 112. Where is this point coming from in the picture? It's right there. Now, why do I have 1/12? Because, as you may know, 1 inch, we need to change it to feet. And, where's my pen? 1 inch is 1/12 of a foot. So once I know this point, this is going to help me find my P. So I go ahead and plug in this x value and the y value into the standard form of a parabola. Opening up, substitute the x and the y, solve for p. This is what I get. Once I know my p, I go back and plug it in here, multiply 4 times 3072, which is my p, and this is the equation of the parabola. Let's go to part B. says how far from the center of the beam is the deflection, or what is also known as the bend, equal to 0.5 of an inch. What you need to understand that two things: 0.5 of an inch, we need to change it to feet, and it's actually 1/24 of a foot. And not only that, this is actually representing a y value. So once you understand that this is the y value, all you need to do is find the x value that corresponds to this y value by using the equation in part A, which is right here. Substitute the y value, simplify this, take the square root of 512, and you end up with 22.6 feet. Let's go to the last one on this section, number 17. For long, says roads are often designed with a parabolic surface that allow to drain off. Parabolic surfaces to allow to drain off. A particular road that is 32 feet wide is 0.4 foot higher in the center than it's on its sides. So here's a picture that goes with the information here. Part A says find an equation of the parabola that models the road surface. You can read the assumed part. Just like number 16, we're going to use a point, which is the point over here. This is, the whole thing is 32, half of it is 16, and then it's opening down. So that's why it's negative 0.04. So now that I know this point, I'm going to, just like on 16, I'm going to substitute this x and y value to find p into this standard form of the parabola, center at the origin, go through the work, p is equal to negative 160. Once I know my p, I go back and plug it in here. I simplify this. This is the equation of the parabola modeled by this situation. Here's part B. How far from the center of the road is the road surface? 1/10 foot lower than the middle. Again, what you need to understand is this actually is a y value, the 0.1, and it's actually negative 0.1. So you substitute negative 0.1 into, let me get a pen, into the equation in part A to find the x value. Once you substitute, simplify, and you take the square root, you end up with 8 feet. This is the answer to part A, and this concludes video 9.1, part 2.